So question 1 and 2 are both very similar, and they're asking us to determine whether it's linear. When looking at equations, for me, it's easier to almost think about what makes something not linear. So I'm going to make a list of no-nos over here on the side. So one big no-no would be having anything with an exponent higher than 1. So that's an example of that would be x squared or y cubed. We can't have that. We also cannot have our variable be our exponent. So something like y equals 3 to the x power. Again, these exponents and having our variable as the exponents makes our line a curve, not a line anymore. And then one more thing that we added was our variables cannot be multiplied together. So we can't have x times y. And then lastly, we can't have our variables in the denominator. So no 3 over x or any number over x or any number over y. We cannot have this. So if we look at number 1 here, it says y equals x plus 9. I don't see any exponents, I don't see any variables being multiplied together, and I don't see any fractions. So yes, this is linear. Number 2, I see the exponent right away. That's a no. Same thing for number 3, and the same thing for number 4. So you see those exponents, that means it is not linear. Linear means something is a straight line. Again, the exponents make it a curve. 2, I look at that, I see 4x equals negative 9. No exponents, no multiplication of the two variables, no fractions, so yes, that's linear. Here I have a fraction, I notice. Again, I've got my variable on the bottom, so that is not linear. On the third one, it does look a little confusing because it has decimals. However, we can eventually clear those decimals through multiplication. So those aren't breaking any rules. So yes, these are linear. And then again on number 4, it's linear because we have no exponents, no fractions, and no variables being multiplied together. So problem 3 says the equation of a line is given below. It gives us 6x minus y equals 6. It wants us to find the x-intercept and the y-intercept, then use them to graph the line. So this is where to find the x-intercept, I change my y to a 0, and to find the y-intercept, I change my x to a 0. So I get 6x. I'm going to find my x-intercept first before I begin, label it. 6x minus, I'm going to change that y to a 0, equals 6. That leaves me with 6x equals 6. I'm going to divide by 6, and I'm left with x equals 1. So I'm going to go over to my graph, and on my x-axis, on my I'm going to plot x equals 1. Then I'm going to go over and I'm going to find my y-intercept. So I'm going to change my x to a 0. So 6 times 0 minus y equals 6. That's negative y, because the 0 disappears, so I'm just not going to rewrite that. And I have negative y equals 6. I'm going to divide by negative 1 to cancel that negative, and divide by negative 1 to get y equals negative 6. And then on my y-axis, I'm going to plot that point. And then I'm going to go and I'm going to connect my 2 points. And we have our line. Always remembering to put my arrows on the end and drawing our line through the entire graph. Then I'm going to go down and I'm going to make sure I list it. I'm going to put 1 and negative 6 for my answers. So problem 4, we are finding the intercepts again. So I am going to go through and I'm going to find my x-intercept. So I'm going to start by finding the x-intercept, and again I'm changing my y to 0. So I have 4x minus 2 times 0 equals negative 8. That leaves me with 4x equals negative 8. I divide by 4, and I'm left with x equals negative 2. So I'm going to go to my x-axis, and at negative 2, I'm going to plot that point. Then I'm going to find my y-intercept. I'm doing the same thing, except now, again, I'm changing my x to 0. That leaves me with 2y equals -8. Divide by 2, divide by 2. And I'm left with y equals -4. And I'm going to plot that point at -4, and then you connect your dots. And then I'm going to put the answers up here. Now, question 5 asks us to graph the line x equals 1. When you have your variable equals a number, so x equals 1 or y equals 1, that's when you get your vertical or your horizontal lines going through that number. So if I have the graph x equals 1, I know that it needs to be the opposite of my axis. So my x-axis currently is right here. It's horizontal. So that means my line needs to be vertical, which is the opposite way. So I'm going to go through 1 on my x-axis, but it's a vertical line. If you cannot remember this, you can go through and make your table, your x and y table, and since it says x equals 1, any point we pick for y, the x value will be 1. So then I can say -2, 0, and +2. So I would plot those points as over 1, down 2, over 1, 0, up 0, over 1, up 2, and I could connect those 3 points. We got the same thing for 6, except now we're going through 4. Just try to remember that it says x equals, so it's going to be the opposite of the x-axis. Problem 7 asks us to find our y-intercept and our x-intercept of the line below. Again, the x and y-intercepts are the points at which they cross that axis. So I like to go through and put the dot on mine, put a point, and where it crosses my x-axis, so we're going to say x-intercept, that's at +2. And my y-intercept crosses at a +3. We're down here on 8. We're finding the y-intercept and the x-intercept. This is what we did on the first page, except now we're not graphing it. We're just finding those intercepts. So I'm going to find my x-intercept first by making my y a 0. 3x equals 6, divide by 3, and I'm left with x equals 2. So on my x-intercept line, I'm going to put a 2. Then I've got my y-intercept, and you make your x a 0. So I've got 3 times 0 minus y equals 6, negative y equals +6, divide by -1 to get y equals -6. Remember, you got to cancel this negative right there. Question 9 is moving on to finding the slope of the line graphed below. Remember, our slope we said is the rise over the run. But before I even begin, whenever I look at a graph, I always ask, what would slope dude say? Slope dude say here he would say puff, puff, positive. So I automatically know. Now I'm going to find, so now from this point, I've drawn our triangle. And remember, the rise is the height of the triangle and the run is the width. And you count the spaces, not the lines. So first I'm going to find my rise, which was 1, 2, 3, 4, 5, 6, 7, 8. And that'll be over my run, which was 1, 2, 3, 4, 5. So my slope is 8/5. Down on 10, we're finding the slope again. There's 2 ways we can do this. You can do delta y over delta x, which is our change in y over change in x. This is where we use a table. Or you can use y sub 2 minus y sub 1 over x2 minus x1 gives you your slope. I'm going to start with the delta y over delta x. This is where you list your points. So I've got 6, -7, and 2, -4, and I find the change to get to each number. So my delta y equals 3, because to get from -7 to 4, I have to add 3. So it's a positive 3. And to get from 6 to 2, I have to subtract 4. So my slope here is my change in y, which is 3, over my change in x, which is -4, and your slope is -3/4. And I'll do it the same way over here with the y2 minus y1 over x2 minus x1. So I have -4 minus -7 all over 2 minus 6. These change to a positive up here, so I'm left with -4 plus 7. That's a positive 3 all over 2 minus 6, which is a -4, and that is also our slope. They both check. Problem 11 says for us to find the slope of the line passing through the points, and then we just do that 2 times. So I like to just use my y2 minus y1 over x2 minus x1. So I'm going to say 6 minus 6 over -9 minus -4. That leaves me with 0 over. Once I see the 0 on top, I'm not going to go any further. I know when I have 0 on top, that means our slope is 0. We need to make sure that we write 0 and not leave it as a fraction, 0 over a number. Now I'm doing the same thing on the second part. I have -3 minus -3. -3 minus -3 all over 6 minus -2. So then I'm left with -3. These change to a positive. That's another 0 on top. I'm not going to go any further. I know my slope is 0. Now if we look at problem 12, it says after crossing the bridge, Juan drives at a constant speed. The graph shows the distance in miles versus the time since he crossed the bridge in hours. What is the slope of the line? I'm going to pick a nice point. I'm going to pick this point 0 here, 50 or 1, 50. So if I'm going to find the slope of the line, I know Slope Man would say puff, puff, positive. So I know my slope is positive. I'm not worried about that. I'm going to look at my rise over my run. My rise is 50. My run down here is just 1. So their slope is 50 over 1, but we just write 50 because we write our slope in the simplest fraction. Now it says how much, this is part B, it says how much does the distance increase for each hour since Juan crossed the bridge? Well, after 1 hour, he's at 50. After 2 hours, he's at 100. After 3 hours, he's at 150. So he moves 50 miles each hour. So question number 13 says, each day Greg earns a fixed wage plus extra money for every hour of overtime he works. The graph shows his total pay in dollars versus the amount of overtime in hours he works. So if you look at the x-axis down here, it's labeled by ones. And that's not how many hours he works in a day. That's his overtime hours. Then if you look at the y-axis, I went there and labeled them. They count by 25s. I know it's blurry. It's just because of the printer and how zoomed in it is. So I labeled them for you there. This first question asks, what is Greg's total pay with 0 hours of overtime? So we go to our overtime hours, we go to 0, and we go up here and we see it crosses at 100. So we're at 0 and we say it starts at 100. So without working any overtime, Greg's total pay would be $100. Part B says, choose the statement that best describes how the amount of overtime and total pay are related. Then fill in the blank. First one says, as the amount of overtime increases, the total pay decreases. Well, it's a positive slope and it's continuing to go up, so that's not going to work. That's a no. So it must be our second one, which says, as the amount of overtime increases, the total pay increases. That's a yes. So what rate is the total pay increase? Well, I'm at 0, it's 100. So I'm going to go to 2 hours, and it crosses at, after 2 hours, he gets, or no, I take that back. We start at 0. I'm going to go to 1 hour. After 1 hour, he gets $175. So from 100 to 175, it increased by $75 per hour. Because if I go to 2 hours, it goes up to $250, and if you take 175 plus 75, that's $250. Problem 14 says to graph the following line. That line is y equals 4x. When I look at this, I recognize that it's a direct variation equation. And when we have direct variation equations, we did the Alex assignment over this. Everyone did excellent on it. We always start our graph at the point 0, 0. Then our slope here is 4. So I'm going to rise 4, run 1. Rise 4, run 1. And I've got a point at 1, 4, and 2, 8. And then I'm going to draw my line. And remember, on this, on your test, you need to have 3 points on this graph to receive full credit. So 15 says, suppose that y varies directly with x and y equals 9 when x equals 18. It wants us to A, write a direct variation equation that relates x and y, and then B, find y when x equals 5. So when I'm working through direct variation equations, I know that that equation is y equals m times x, and we've also seen it as y equals k times x. Whatever I do first to come up with our equation, since it gives us y and x already, I need to find that m and substitute that in. So I'm going to say 9 equals k times 18. Now I'm solving for k. You could have done 9 equals m18. It's the same thing. I'm going to divide by 18. Divide by 18. Those cancel. And I'm left with k equals 1/2. So, to get my equation, I take my y equals, and I substitute my k value in, 1/2 x. Part B now tells me to find y when x equals 5. So I use this equation here and substitute a 5 in for x. So that gives me y equals 1/2 times 5. I multiply straight across. That gives me y equals 5 over 2. And that's your final answer. Question 16 says that for each equation, determine whether it shows a direct variation. It shows that it's directly proportional variables. If it does, find the constant of variation and write it in simplest form. So our direct variation equation looks something like y equals k times x. If I see a number that is not being multiplied by x or y, if there's an extra number, a constant, that means it's not direct variation. So if we look at the first one, it says 7x plus 6y equals -1. I have this -1 here. That makes it not direct variation, because when I go to solve for y, if I get 7x plus 6y equals -1 and I try to put it in this form, I get 6y equals -7x minus 1. I divide by 6. I divide this entire thing by 6, and I'm left with y equals -7 over 6x minus 1 over 6. Because of this here, that's not direct variation, because our variables aren't directly proportional. So this is a no. Down here, I've got 14x minus 7y equals 0. Well, I can put this in the form of direct variation because we have just a 0 here. So I get 14x. I'm going to add 7y to both sides. I want to put it in the form y equals k times x. And I'm left with 14x equals 7y. I'm going to divide by 7, and I'm left with y equals 2 times x. Well, yes, that's direct variation. There's nothing extra, and my k value is 2. Problem 17 tells us that the first 3 terms of an arithmetic sequence are as follows. We have 19, 28, and 37. It wants us to find the next 2 terms. So when I look at this, the first thing I'm going to do is I'm going to find that common difference. So I would just, because we're increasing, I know it's going to be a positive number. I'm going to take my bigger number minus my smaller number, so 28 minus 19. And I'm left with 9. So the common difference is 9. So I'm going to take 37 plus 9 to get my next term, which is 46. And then I'm going to take 46 and add 9 to that, which leaves me with 55. That's all you got to do for 17.
So we have to only...
Question 18 says, for each sequence, determine whether it appears to be arithmetic. If it does, find the common difference. So with our arithmetic sequences, we remember that that common difference is a number that we add or subtract each time to get the next number. When we multiply or divide, that's not arithmetic. That's what we call geometric. So I'm going to look at 2 to 10. Well, if I went from 2 to negative 10, I would subtract 12. But now I'm going from negative 10 to 50. I would have to add 60 to get that. That's not constant, so that's right away not arithmetic. On the next one, I'm going from 12 to 15. That's plus 3. 15 to 19, that's plus 4. And 19 to 23, that's plus 4. Not constant, not a common difference, not arithmetic. Now we're going from 9 to negative 16. I got to subtract 7 here. Negative 16 to negative 23. I'm subtracting 7 again. Negative 23 to negative 30. I'm subtracting 7 again. So yes, this is arithmetic, and our common difference is negative 7. Not 7. It is a negative 7. So question 19 says to find the 71st term of the following arithmetic sequence. So it gives me 12, 20, 28, 36. I'm going to use this formula over here, and I'm going to fill out what I know. So A sub 71, because we're trying to find the 71st term, equals my first term, which is 12, plus my n is 71 minus 1. Now I got to find my common difference. Well, 12 to 20 is plus 8. 20 to 28, that's plus 8. So my common difference is 8. Now I'm going to just simplify, and that's how you get your answer. 12 plus 70 times 8. I know 8 times 7 is 56. Add the 0, I've got 560 plus 12. My final answer is A sub 71 equals 572. Question 20 says, find the 16th term of the arithmetic sequence whose common difference is D equals 6 and whose first term is A sub 1 equals 1. So the first term is 1. I'm going to use my formula and just fill out what I know. So I'm looking for the 16th term, and it tells me my first term is 1. My n is 16, and my d is 6. These are all given to me. You simply need to plug it into the formula, put it in your calculator, and get your answer. You might not even need a calculator for this one. So now you just simplify. 1 plus 15 times 6. 6 times 10 is 60, plus 5 times 6 is 30. 60 plus 30 is 90, plus 1. A sub 16 equals 91. That's your answer.